All right, here we go. States of matter. All right, you guys know this. Now, if we talk about, well, looking at our textbook, we're here, solids, liquids, and gases. All right, what's the big idea here? Rainier, read that statement to us, please. Very good. Many physical properties of matter can be described by the motion of particles. I'm going to attempt my best to draw solid particles, liquid particles, and gas particles. Now, one thing that you can see here, and I want to make sure that y'all see this, do you see the fact that they're trying to show there's a little bit of motion in these particles, right, William? You see this kind of doodad here showing that these particles are moving a little bit, all right? These are solid particles. Solid particles move a little bit. How do liquid particles move compared to solid particles? A little bit more. They slide around a little bit more. That's why when you have a liquid, all right, if this is my coffee, what are these liquid particles able to do when I swirl my cup around? You see them moving around. You see the reflection of the light as they move around, all right? Do you see the textbook, solid, the paper, the pages, the solid particles moving around? No, we don't. They are moving around a little bit, but we don't see that motion at all. All right? What about gas? It's hard to see gas moving, but what if you could see gas? What would you see? What if you could see the air particles? What would you see them doing? You'd see them swirling around. Have you ever seen like a dry ice or like a fog machine? A lot of times, maybe like at Halloween or like at a concert, they'll have like fog, and you can see it moving, right? Cigarette smoke is actually solid particles in the air that are kind of floating on the gas, on the air molecules. Those particles are solid particles, but they're so tiny that they're moving around on the air molecules. So that's why you see them moving around like a gas. That's a good question. All right. Shh. Now, let's do this. Let's talk. Let me write this before you write this down. What state of matter am I talking about right here? Solid. All right. This is solid. Shh. Now, if I talk about something like this, okay, now I'm going to show it in a container, actually. Okay, let's show this in a container. Now, what's the liquid doing that the solid didn't do right here? In a minute, you're going to draw this, but I want you to wait just a second so you can see the whole thing here. Now, over here in my container, what are the gas particles going to do? Are they going to settle to the bottom, or are they going to go all over this container? They're going to go all over this container. Now, the reason I'm having you wait just a second is because I want to talk about the state changes that are happening here. All right? This is the gas. All right, here are the state changes we're going to talk about. Now, let's say you have solid. And when I have you think of a solid, I want you to think of, let's say, water, okay? What is solid water called? Ice. When ice changes to water, what is that process called? Ice changes to water is called melting, right? Okay, so I'm going to write melting, all right? Now, what's the opposite? Water changes to solid ice. Freezing. Good. You know this. You know this. All right. Now, liquid to gas. That's this right here, right? That's your pot of water on the stove, all right? And what's happening to it? What's that process called? Boiling. Now, what's that process called if it doesn't happen so quickly? Let's say I take my water and I take the lid off and let it sit for a couple days. What's that going to be called? Evaporation. All right? Or we can call it vaporization. All right? Now, The opposite of that is what happens when you have, let's say you go to the QT and you get yourself a really cold drink in the summertime. You set your cold drink on the table. What happens to it after 30 minutes? Condensation. Where is that condensation forming? On the inside or the outside of your glass? It's forming on the outside of your glass, all right? And that happens because what's in here is cold and the outside air is warm. And what's happening to the gas particles out here? It's actually the water molecules. They are condensing right here on the side of your glass, aren't they? Okay, so that's gas becoming liquid, and it happens on the outside of your glass. When else do you see condensation? At your home or in the car? Actually, the dew on the grass is condensation. And on your windows, when does it happen on your windows? It can happen in the summertime, right? If it's cold in your house and it's hot outside. Yeah, when you run in the shower, if the hot shower has been running, it happens on your bathroom mirror, right? Okay? It's anytime you have that warm air and it's condensing against a cooler surface. Now, this is the one that we are not super familiar with. Jarrett, you and I, we know these things, don't we? Us Milums. Okay, sublimation. When we go from solid to gas, when does a solid go to a gas? What's an example of this? Not melting. Melting is this. Dry ice, which is actually solid carbon dioxide. Did you know that? Solid carbon dioxide is dry ice. Dry ice sublimes. You have this big chunk of ice, and what does it do? It looks like it's smoking, but it's not smoke. It's actually gas, okay? So you have your solid going straight to the gas phase. Dry ice does not melt. It doesn't melt. It goes straight from solid to gas. Now, you can have liquid carbon dioxide, but not at standard pressure. If you got it really, if you change the pressure and the temperature to a certain point, then you could get liquid carbon dioxide. All right. Moreland, you have a question? If you touch dry ice, it's very, very cold, and you say that it burns you, although it's not a hot burn, it's a cold burn. Yes, Mackenzie? Liquid nitrogen. Liquid nitrogen you'll have in one of these gas tanks, all right? Shh. And you have gas nitrogen. Well, normally you'd have gas nitrogen, but you put it under such high pressure that it becomes liquid nitrogen, all right? Oh, let's finish this up. The opposite of sublimation, all right? The opposite of sublimation, is when the gas turns into a solid. This starts with a D, and I bet that y'all don't know this one. It's the word deposit, but we've changed it into the word deposition. Everyone say deposition. Deposition. All right, you need to have this diagram written down. Have this diagram written down. You got it?